Assalamualaikum. We are from Group 10 will present regarding rock cycle and origin of soil. I am Muhammad Daniel bin Fatih Sham.
I am Abdul Azim bin Salahuddin.
I am Farhana binti Samsul.
And I am Philip Lionel Peter.
Alright. For the rock cycle, Farhana and I will explain about it, and for the origin of soil, Abdul Azim and Philip will explain about it. Okay, let's get started. What is rock cycle actually? The rock cycle is a concept used to explain how three basic rocks, which are igneous rock, sedimentary rock, and metamorphic rock, are transformed from one type into another through a process. The earth process is solidification, weathering, erosion, deposition and burial, lithification, and metamorphism, thus creating what we call now as rock cycle. And the rock cycle begins with magma, or we can call it as molten rock. Magma is formed from the melting of rock. As you can see from this picture, magma originates from a lithosphere and atop asthenosphere. Okay, because magma is less dense than surrounding underground solid rock, it will rise towards surface and erupt through volcano. It may settle within the crust or erupt at the surface from the volcano. And in underground, we call it as magma. And at the surface, we call it as lava. And when this magma gone through solidification process, it will form igneous rock. Solidification is the process where a molten liquid becomes a solid. Solidification process can occur whether inside the earth crust or at the earth surface. And this process can be complicated as different range of temperature will determine which mineral will crystallize first. However, this will be discussed in detail in Bowen's reaction. Farhana, you may continue.
Okay, there are two types of igneous rock. The first is extrusive igneous rock or volcanic. It forms, cool and solidified in the earth's surface. The molten rock erupts and flows above the surface as lava and then cool, forming a rock. It cools quicker with no crystal or a very small one and produce fine grain. Sometimes they cool so fast that no crystal form at all. The extrusive rock with no crystal are called glassy. And the second one is intrusive igneous rock or plutonic. It forms, cool and solidified below the earth's surface. The molten rock called magma flows into crack or underground chamber and then it sits and cools very slowly and form lush green or coarse green. The example of extrusive igneous rock is tuff, scoria, rhyolite, pumice, obsidian, dacite, basalt, and andesite. An example for intrusive igneous rock is pematite, pyridite, diabase, diorite, granite, and gabbro. For Bowen reaction series, Bowen determined that specific mineral form at specific temperature as magma cool. In this diagram, it has two sequences. On the left side is discontinuous series. It describes mafic mineral. At the high temperature, the olivine is the first mineral to form, followed by pyroxene, amphibole, and biotite mica. Biotite mica is the last mineral and officially end of this series. If the mineral hasn't cooled completely or has plenty liquid, it will continue to cool and form potassium feldspar, muscovite mica, and quartz. These three minerals crystallize at the lower temperature, and the right side is continuous series. The continuous series describes evolution of plagioclase feldspar as they evolve from being calcium-rich to sodium-rich. And then the down-pointing arrow shows the increasing amount of silica, sodium, aluminum, and potassium as mineral composition goes from ultramafic to felsic.
Farhana, I have a question. What rock is likely to have potassium feldspar, muscovite mica, and have crystal large enough to see with naked eye?
Because of these three minerals are intrusive igneous rock, as we already know, this rock cool inside the surface of the earth. The cooling process takes thousands or millions of years to produce crystal. The crystalline structure is large enough to be seen with the naked eye. Azim, you may continue with the rock cycle.
Alright, Farhana, thank you. When igneous rock or metamorphic rock undergoes weathering and erosion process, it will form sediment, and even sediment will become sediment again if it goes through erosion process. Okay, what is sediment? Sediment is fragment of rock that have been broken down due to weathering and erosion. Weathering makes existing rock crumble or break down into small fragments. You can see here the picture tells it, and the example of weathering are physical, chemical, and biological weathering. However, this will be detailed explained in origin of soil. And Once rock has been broken down, the erosion process will transport the fragment away. The movement by water, ice, wind, gravity, and rain, just as described from this picture. Alright. When sediments undergo deposition and lithification, it will form sedimentary rock. Alright, Fahana, you can explain detail.
For sediment to become sedimentary rock, it undergoes deposition, compaction, and cementation. Deposition, sediment settle in a place, and compaction is compacting, squeezing or compressing rock together. And cementation is dissolved mineral crystalline and gluing, sticking or cement sediment together. These are three major categories of sedimentary rock. The first is classic sedimentary rock, composed of sediment that are compacted and cemented together. They are classified by grain size, grain shape, color, mineral composition, and texture. The size is more than 2 or 4 mm or larger for the biggest one. The common rock is conglomerate, breccia, sandstone, siltstone, and shale. The second is chemical sedimentary rock, causes for evaporation or precipitation of mineral. The rock name is chert, rockshale, rock gypsum, and dolostone. And lastly is organic sedimentary rock, formed from accumulation and lithification of organic debris or dead organism. For example, coal was created from plant, limestone created from oyster or clam, phospholiferous limestone created from large number of fossils. Alright, Daniel, goes to you.
Alright, thank you, Fahana. Okay, when sedimentary rock or igneous rock undergo metamorphism, which they are imposed to heat or pressure, the high intense of heat and pressure, it will form metamorphic rock. Rocks change during metamorphism because the minerals need to be stable under new temperature and the pressure conditions. So the need of the stability causes the structure of minerals to rearrange physically and chemically and form new material, thus forming metamorphic rock. To classify metamorphic rock, there are two, which are foliated and non-foliated. Foliated is formed when mineral grains grow, rearranged, and line up in parallel layer. This occurs because of directed pressure or shear stress, and also directed pressure and heat. From this picture, you can see that when the rock is squeezed under directed pressure, it will undergo deformation, resulting the minerals to be elongated in perpendicular direction to the shear stress or shear pressure, thus lead to the formation of foliation. And from this picture, when the rock is squeezed and heated during metamorphism, the temperature change form a new mineral, a new parallel mineral grains layer that grow perpendicular to the direction of pressure. Okay. And when the metamorphic rock that doesn't form parallel mineral grains layer is called the non-foliated metamorphic rock. The mineral grains grow and rearrange, but it does not form layers. This is due to it is exposed to heat only. And for the foliated rock, example are gneiss, schist, slate, and phyllite. And for the non-foliated rock, marble, skarn, hornfels, novaculite, and quartzite. Alright, types of metamorphism. The first one is contact metamorphism. It involves the intrusion of intense heat which come from the magma or lava with the existing rocks. This will produce non-foliated metamorphic rock as it only involves heat only. And usually the contact metamorphism occurs in small area compared to other types of metamorphism. And the second one is the regional metamorphism. This metamorphism is associated with pressure. This pressure comes from geologic process such as convergent plate boundary and mountain building process. High pressure from the process causes the rock to deform and lead to the foliation of rock, hence creates the foliated metamorphic rock. This geologic process occur in wide area, so the regional metamorphism affect large. And you can see from this picture, the rock that is trapped in the middle will be subjected to high pressure and form foliated metamorphic rock. And for the third one is dynamic metamorphism, which are the combination of heat and pressure. From this picture, we can see that as the intensity of metamorphism increase, the grade will also increase, which are low grade to high grade. And the parent rock shale, for example, rock shale, with the increasing of metamorphism, it will form slate, phyllite, schist, and lastly, migmatite. Migmatite is a high-grade metamorphic rock.
I'm sorry to interrupt, Daniel, but I have a
Yes.
question. What happens if the metamorphic rock exposed with too much heat and pressure? I mean higher than the migmatic metamorphism.
Oh, great question. Okay, if that happen, The answer is that the metamorphic rock will melt down and become magma again. Then the rock cycle will begin to continue again and again over time and won't ever stop. Hence, ensuring that the Earth, never runs out of rocks.
Okay. Thank you.
For the origin of soil, you may continue, Azim.
So the following part is origin of soil. So first of all, what is soil? Soil is the loose surface material that covers most land. It consists of inorganic particle and organic matter. Soil provides the structural supports to plants used in agriculture and also their source of water and nutrient. So next, soil formed through accumulation and decay of organic matter and through the mechanical and chemical weathering processes. The factors that affect the nature of soil and the rate of its formation include as below. Climate, the type of parent material, the slope of the surface, the amount of time available, and also organism. So first is weathering. So what is weathering? Weathering is the process of breaking down rocks by mechanical and chemical processes into smaller pieces. Mechanical weathering may be caused by the expansion and contraction of rocks from the continuous gain and loss of heat, which result in ultimate disintegration. Frequently, water seeps into pores and existing cracks in rocks. As the temperature drops, the water freezes and expands. The pressure exerted by ice because of volume expansion is strong enough to break down even large rocks. It is important to realize that in mechanical weathering, large rocks are broken down into smaller pieces without any change in the chemical composition. The freezing and the thawing action of water on the surface fractures the rock and creates large cracks and a drainage pattern in the rock. Over a period of time, unweathered rock is transformed into large boulders.
I'm sorry, Abdul Azim.
Yes.
I want to ask that, is there any other physical agents that help disintegrate the rocks?
Yes, of course. Other physical agents that help disintegrate rocks are glacier ice, wind, the running of water of streams and rivers, and ocean waves. So moving to the next part. In chemical weathering, the original rock minerals are transformed into new minerals by chemical reaction. Water and carbon dioxide from atmosphere form carbonic acid, which reacts with the existing rock minerals to form new minerals and soluble salt. Soluble salt present in the groundwater and organic acids formed from decayed organic matter also cause chemical weathering. The minerals formed at higher temperature in Bowen's reaction series are less resistant to weathering than those formed at lower temperatures. Thus, we can see how weathering process changes solid rock masses into smaller fragments of various size that can range from large boulders to very small clay particles. Uncemented aggregates of these small grains in various proportions form different types of soil. The clay minerals, which are a product of chemical weathering of feldspar, ferromagnesium and micas, give the plastic property to soils. So next is climate. Soil development is facilitated by the downward percolation of water. Soils form most readily under temperate to tropical conditions and where precipitation amounts are moderate. With a colder and drier climate, these processes can be slow, but with heat and moisture, they are relatively rapid. Too much water can lead to the leaching of important chemical nutrients and hence to acidic soil. In humid and poorly drained regions, swampy condition may prevail, producing soil that is dominated by organic matter. Too little water result in very limited downward chemical transportation and the accumulation of salts and carbonate minerals from upward moving water. Soils in dry region also suffer from a lack of organic material. Over time, this process can change the soil, making it less fertile. So next, Philip, you may continue.
Okay, thank you. So I will continue on the factor that affect the nature of soil. So the first factor that affect the nature of soil is perimetrial. Basically, soil mineral from the basis of soil, they are produced from rock, which is perimetrial through the process of weathering and natural erosion. The type of perimetrials and the condition under which they break down will influence the properties of the soil form. For example, soil formed from granite are often sandy and infertile, where basalt under moist condition breaks down to form petalite and clay soil. For example, a minor constituent of granitic rocks is the calcium phosphate mineral apatite, which is a source of important soil nutrient phosphorus.
Philip, I have a question. How does perimeter influence the type of soil form?
Okay, very good question. Basically, perimetrial influence the soil formation through their mineralogical composition their texture, and their stratification, which occur in layers. Okay, thank you. So I will continue on the slope of the surface. So the shape, the length, and the grade of a slope affect drainage. The aspect of a slope determine the type of vegetation and indicate the amount of rainfall received. This factor change the way soil form. Soil material are progressively moved with the natural landscape by the action of water, gravity, and wind. For example, heavy rains erode soil from the hills to lower areas, forming deep soils. The soil left on the steep are usually shallower. In this picture, we can see the transported soil. The first one is alluvial, which is water transported, and the second one is colluvial, which is gravity transported, and the last one is aeolian, which is wind transported. The next factor that affect the soil is organism. So soil formation is influenced by organisms such as plant, microorganism, which is bacteria and fungi, growing insect, animals, and humans. As soil form, plants begin to grow in it. The plants mature, dies, and new ones take their place. Their leaves and roots are added to the soil. Animals will eat plants and their waste, and eventually their bodies are added to the soil. This begins the change of soil. Bacteria, fungi, worms, and other growers break down plant litter and animal waste and remains to eventually become organic matter. This may take the form of peat, humus, and charcoal. The last factor is time. Soil properties may vary depending on how long the soil has been weathered, and minerals from rocks are further weathered to form material such as clays and oxide of iron and aluminium. Okay, thank you.
All right, thank you, Philip, for your explanation. Thank you, guys. And for the soil exploration, this is our soil exploration team. Due to SOP, we only send team representative with other groups. And we do the soil exploration at Tasik Kejutaraan. This one, the soil sample is nearby the lake. We determine from the texture by rubbing the sample of soil between forefinger and thumb. Then we firmly squeeze the soil sample in our hand. This sample, as you can see, has brownish grey color with soft and creamy texture and middle-range plasticity. And the soil sample is a bit sticky, and when we hold it, the shape is maintained. But with high squeezing from hand, its shape will crack or break apart, and it retains a little moisture. Hence, we determine this soil sample as seed clay. And for this one, this also at Tasik Kejutaraan, but a bit far from the water lake. This one we determine is as silt. Silt usually has spherical shape, and when we rub it, it gives soapy or slippery feeling between fingers or our palms. Silty soils usually are finer but smoother in texture. So that's about our soil exploration. I guess that's all about our rock cycle, origin of soil, and soil exploration. Thank you, guys. Thank you, everyone. Thank you.